Francis Lane.
One place here at Whipple Hill that my son used to love to go to, and you'll see why when we get up there. How many have ever been to Whipple Hill before? Oh, good. Okay.
It's a great place to see lunar eclipses.
Oh, wow, spectacular. Yes, this is a wonderful place, and you'll want to come back many times, I think, for people who haven't been here before.
But bring a compass.
But bring a compass, yes, and know how to use it. Be sure that it works first before you leave. I also wanted to ask just a little bit about your background in geology. How many have ever studied geology before? That is, it's not necessary to have any background in geology to lead this walk. I'm going to give you a little quick Geology 101 course.
Yes.
Your kids have been studying rocks and minerals in class, and so they already know something about how to observe a mineral and how to observe a rock. They don't know too much about interpreting them, and so we're sort of pushing the envelope a little bit as far as that goes. So I'm going to give you more, much more than the kids will need to know, but just for your own background and benefit, because this is sort of an adult learning experience too. So I want to be sure that everybody has a copy of the walk, and people I think from 5th probably don't.
Oh,
No,
actually, I
put
think
some
we
on
do.
clipboards,
Yeah,
Okay.
yeah.
Who doesn't have a copy of the walk? Start our trip is we're going to start right here in the parking lot. And in this area we have 4 different activities. So when you arrive, you'll have groups of 4, or I don't know how you want to divide them. Bowman, I think you have a different plan. Or you'll have 4, but with more adults. Yeah. That's right. So you probably want to decide who's going to do what first. Okay. First off is looking at that rock wall. Just everybody turn around, just look at it from here. Okay. It looks like your normal rock wall that you see everywhere in Lexington, right? What we want to do is to make those rocks talk. Okay? Now I always ask the kids, have you ever heard a rock talk? And they look at you kind of funny, you know. I say, by the time you finish with this expedition, you're going to be able to listen to a rock and it's going to be able to tell you a story. So that's sort of the line that we're thinking of with this walk. Okay, it's sort of like a detective story though, because we're going to look for clues. Now the first clues that you need to know about rocks has to do with the way they look. So I'm just going to put some big samples of rock out here and ask you, are they all the same?
Nope.
No. Okay, that was easy. How are they different?
Different colors.
Okay, different colors. Anything else that's different?
Shape.
Size.
Different
Shape. Yeah. Okay. If I put let's see, another rock out here like this. If you were comparing rocks, which 2 would you say were most like each other?
The 2 round ones.
2 round ones. Okay. Because
They're round and they're lighter colored.
okay, they're lighter colored, they're rounded, and what about these 2? Are they like each other in any way?
Similar color, definitely.
Okay, similar color and definitely different size. Okay. Now what we're going to go for here is to look for characteristics of rocks that wouldn't have to do with the size necessarily, because I could take a rock hammer, in fact I did, and bang this rock in half. And would it still be the same kind of rock if I had the other half here? Okay, so size is not going to be the most important thing. Okay, when we're looking at rocks right now, the most important thing is what you noticed right away was color. Okay, and what makes this rock dark and this rock light, would you say, just from observing them? It'd be easier if you could see them more closely, but why do you think? Yeah, why don't you move
Different
into-
minerals or?
Yeah, there. See those little specks in them? Okay, the little specks in these rocks are different minerals. And in this particular area in Massachusetts, in Lexington, that is, there aren't any rocks that are what they call sedimentary rocks, that are made out of like grains of sand that are stuck together. All of the rocks that we have in Lexington are rocks that are made out of crystals that have grown in together. So each of these little dots here is a crystal, and it's mushed right up against another crystal. So you can see crystals of different colors. Okay, now what does that mean? We have our here's a larger version. Okay, you've seen things like this, I think, probably in buildings. Each of these little dots is a crystal, and they're all squashed together. And the crystals in this rock originated from rock that was melted. They call that magma. And that magma, in this case, took a long time to organize itself so that the crystals could grow large enough for you to see. You can definitely see different colored spots here. You can definitely see different colored spots here. How about this one? Can you see different colored spots? Yep. Okay, so all of these things are considered large crystals. With this one, you have to look, but you can definitely see different colored, they're almost the same color, but you can see different colored little blobs in there. And even with this one, if I hold it in the light, can you see the sparkles in the light? Okay, each of those sparkles comes from a place where a crystal has been broken. So even this one has got large crystals, even though you have to look closely to see them. Now, let's see. These are, I'm going to pass these out so that I think every 2 people or 3 people can see one of these patterns. And actually, you brought your own.
Yeah,
so,
should I?
yeah, you can do either way, just so people can see them close up while we're chatting here. Okay. Now, do you recognize some of the rocks that are on the ground in the box? Can you see any that look sort of like
The Whipple Hill rock.
Okay, Whipple Hill rock. Which of, yeah, if you look in the box and then you look on the ground at a rock, now this is sort of our simulated rocks on the ground situation, which one looks most like the Whipple Hill rock?
Big dark.
The big dark one? Okay, does everybody vote for this one? Okay, I don't know, I'm going to hold it close.
Yeah, that's pretty good.
Yeah, okay. From your box, what would you call that rock? What's its name? It may be something that you've never said before, so don't. Gabbro, that's right.
So
Okay.
Gabbro,
So it looks pretty
yeah,
close?
they are the same. So this-
Okay, and I see those have come loose.
Yeah.
I know I've reverted to using Elmer's glue this time, so we'll see whether Elmer's glue works
Yeah, I
better
was
than
going to
hot
say,
glue.
they're stuck in
Yeah.
here. The last time
Well-
they were all gone, and it was like,
Were they
I don't
really?
know.
Oh no. Yeah,
like,
I
which
should
is
I should
which?
probably also put numbers on them just in case they get loose. Okay. Yeah. So just matching them up. The name of this rock is Gabbro. Okay. Let's
Never even looked at
practice
these.
with this one that looks. I like to call these salt and pepper rocks. You know, if you mix salt and
Hmm.
pepper together, they look like this. Which one looks most like salt and pepper mixed together?
Diorite?
Diorite. That's right. Okay. And then how about this light-colored one? Now, I should tell you, I don't think the people with the new boxes have got that one
Yeah, I
because
don't
I ran out.
Oh,
But you folks do.
There's other ones.
Yeah. Well, oh, maybe you don't either.
so.
Let's see.
must be this one. This is the extra.
Let's see.
I don't
Is there one
think
that's
it's in here.
missing? Not in there either? Oh, okay. All right, I guess you're missing. Okay, well, sometimes this looks pink. That's a clue. And pink granite, that's right. So if that's pink granite, what color granite is this?
Well, this is pink
This is
granite.
white granite, that's right. And here's
It's similar but just a different
pink
color.
granite with really big crystals. Now, the other clue, so that one of the clues that you're going to look for here is, what is the color of the rock? What are the size of the crystals? And anything else that you can say about the rock. Now, many of the rocks here, actually these aren't really good examples, but many of the rocks that you see in the wall are going to look like this, the kind of dirty old rocks. What you need to do is to try to find a place where they've been freshly broken. Okay? Now, it turns out that some of the rocks in this wall have been freshly broken a little bit, because I have my rock hammer here and I didn't think anybody would mind. So if you look for some of the chips in the rock wall, you'll see some places where you might be able to see crystals. Now, in your box, you can tell what some of those sparkles are, because the sparkles in this rock come from a mineral that you have there. Yeah. Where's the, what? Yeah. And what color mica do you have in there?
Black.
Yeah, that you can see, the kids will know that the mica also comes in white. Okay. Now there is a difference between the first 4 samples in the box and the last several samples in the box. What's the difference between them?
First 4 are pure minerals.
They're more smooth.
Yeah, okay, the first 4 are pure. I mean, I tried to get them as much as possible. Just one kind of stuff, okay? And then the other ones are all mixtures of minerals, okay? But actually, they're all rocks. So a rock is made out of one or more minerals. And when you see a rock like this, all the little dots just represent all those other minerals that you see in there. Now, some of them people pretty much know, like quartz. A lot of people will know what quartz is. But you have to look really carefully to tell the difference between quartz and white feldspar. So do that right now and tell me the difference between quartz and white feldspar. Now, a trick is to move your carton
This
and
is
look
which?
at the way they reflect.
This is
light.
quartz and white feldspar.
Okay, what's the difference between them?
Quartz looks whiter.
Okay, and then you need to move your carton every which way and move it in the sun. Take a look at the way that, yeah, that's it, okay. You get anything unusual about?
We've got 2, so she's probably going to bring more. Okay.
And how about the?
Looks more sparkly.
Okay.
Less translucent.
Okay. Did anybody notice something about the way the feldspar reacts to light? Just move it around in the carton there.
It reflects more than the quartz.
Always? Or just at one place?
Just in the place.
Yeah,
kinda
sometimes
dull.
it looks dull, but if you move it around and move it around, you'll get one place where it flashes. And you notice why it does that.
Because it's more opaque, less
Uh,
translucent,
Well, why would it flash though?
because it's a flatter surface.
Did you notice that it's flat?
Oh, I see one place.
When it breaks, it breaks along a flat surface. If you break quartz, it breaks like glass. It just any old which way. I mean, it's shiny, but it's shiny all the time. But feldspar is just shining in one direction. So now, should pink feldspar also have that quality? Try it and see. The pinkness is because it's got something else.
It's got that
It
shine
does,
to
yeah.
it.
It has an impurity mixed in that makes it pink. There's also green feldspar at Pikes Peak, which is beautiful. And, yeah. Okay. Now, if you look in that granite in your sample, I think you don't have the white granite. What mineral makes it pink? Pink feldspar. You got it. Okay, so that's good. So that's what we're going to be looking at. Now, with the darker rocks, it's very hard to tell. The kids won't know what these minerals are. I don't really even have samples of them in your box, okay? But it's just enough to say that the rock is dark. So we're just looking for differences in the rock, okay? Now we're going to look at the rock wall and compare the kinds of rocks we're seeing down here with the rocks that we see at the top of the hill. That's part of the mystery, okay?